Hello friends, welcome back to Relief Tutorial. Yesterday we have discussed some important formulae. So I am going to recap this formula. Root AB is equals to root A into root B. So if there is a product of two numbers, you can give separate roots to both the number and write product. Here A upon B division, so you can give root to both the number. Then we have seen here, if you know that x plus y, x minus y, difference of two perfect squares, so x square minus y square. So if there is root a plus root a minus root b, so first term is root a, so root a the whole square. Second term is root b the whole square, and here minus. So square and root will get cancelled, so a minus b. Clear? Same thing we have discussed this. Now a plus b the whole square, you know that. So this formula we have discussed. Based on this formula, we are going to do certain problems. Clear? See. Now we will do textbook example 16. See. Textbook example 16, here it is given. First one, 5 plus root 7 into 2 plus root 5. So this is the problem. Okay, so how we will do, you know that there is no identity here. All numbers are different, so you will multiply this. So 5 into 2 plus root 5 and root 7 into 2 plus root 5. So 5 into 2. So 5 into 2 directly I can write 10. 5 into 2 10. Then 5 into root 5. So plus 5 root 5 plus root 7 into 2. So 2 root 7 plus root 7 into root 5. So root 7 into root 5 is root 7 5s are 35. Here you see this is our answer. These are not like terms. Why? Because here is root 5 and here it is root 7. So you can't add these two terms. Clear? First one. Now second one. We have 5 plus root 5 and 5 minus root 5. See here. Both that term is same. A and B. Here plus, here minus. So A plus B, A minus B. So A square minus B square. So 5 square minus root 5 the whole square. So 5 square is 25 minus root 5 the whole square is 5. So 25 minus 5. So answer is 20. Clear? Then third one. Root 3 plus root 7 the whole square. So a plus b the whole square. So you know a square. A square means root 3 square plus 2ab. 2 into root 3 into root 7 plus root 7 the whole square. Otherwise you can write directly here root 3 the whole square is 3 plus 2 into root 3 into root 7. This 2 into root 3 into root 7. Root 7 into root 3 root 21. So 2 root 21 plus root 7 the whole square 7. So now 3 plus 7 10 plus 2 root 21. So this is an irrational number. This is rational but this is irrational. Now fourth one. See root 11 minus root 7, root 11 plus root 7. See look here, first term is same x, second term is same y, x minus y, x plus y. So x square minus y square. So root 11 the whole square minus root 7 the whole square. So here root 11 the whole square is 11 minus root 7 the whole square is 7. So 11 minus 7, answer is 4. So in this way you can do the problem. Clear? Now see, if we go to our exercise 1.7, exercise 1.5 textbook. Question number here 2. Simplify each of the following. You have to simplify each of the following. See now. So here first one 3 plus root 3, 2 plus root 2. See there is no identity here. So you have to multiply this. 3 into 2. So 3 into 2 is 6. 3 into root 2. So plus 3 root 2 plus root 3 into 2. So 2 root 3 plus root 3 into root 2. Root 3 into root 2 is root 6. So this is our answer. Clear? There is no like term here. You can't add anything. First one. Now second. 3 plus root 3. 3 minus root 3. See look here. X and y plus minus. So x plus y, x minus y. So x square, that is 3 square minus root 3 the whole square. So 3 square is 9 minus root 3 the whole square is 3. So 9 minus 3 is equals to 6. Clear? Third one. Root 5 plus root 2 the whole square. So a plus b the whole square. So a plus b the whole square means a square. Root 5 square is 5. You can write plus 2ab. 2 into root 5 into root 2 plus root 2 the whole square. So here root 5 the whole square is 5 plus 2 root 5 into root 2 root 10 plus root 2 the whole square 2. So 5 plus 2 is 7 plus 2 root 10. Clear? Now fourth. Root 5 minus root 2 root 5 plus root 2. Clear? So here a minus b, a plus b. So what you will write? Root 5 the whole square minus root 2 the whole square. So that is equals to root 5 the whole square is 5. Root 2 the whole square is 2 minus 5 minus 2. Answer is 3. So we have completed second question. Now we will learn totally a new topic that is called rationalizing the denominator. So we are done. Now rationalize the denominator. Rationalizing the denominator. So rationalizing the denominator. Clear? So we are going to learn totally this new topic. What do you mean by rationalizing the denominator? See, if denominator contain a terms, for example, see here, if it is 1 upon root 2, so this denominator has this radical sign. This is called radical sign or square root. So, if a denominator of an expression contains a term with a square root, then the process of converting it into an equivalent expression whose denominator is a rational number is called rationalizing the denominator. Means there should not be any root, irrational number in the denominator. So what you will do, see here, 1 upon root 2. So you will multiply this with root 2 and you will divide by root 2. So you are multiplying numerator with root 2 and you are multiplying denominator also with root 2. So this root 2 will get cancelled. So it will remain as it is. So now 1 into root 2 is root 2 upon root 2 into root 2. So you know here root 2 into root 2 is equals to root a into root b and root 2 into 2. So that is equals to root 4 and root 4 is 2. Or root 2 into root 2 you can write root 2 the whole square. So this square and root will get cancelled. So answer will be 2. Clear? So root 2 into root 2. So you know that will be 2. Root 2 by 2. So here it is. There is no radical signs or square root in denominator. These both are equivalent. Their values are equal. 1 upon root 2 is equals to root 2 upon 2. Both are equal. So this is called rationalizing the denominator. Denominator is converted into a rational number. So it is called rationalizing. It is converted into rational number. So it is called rationalizing. And you know that, suppose, see, conjugates. You have to learn about these conjugates. What are conjugates? See, conjugates of root a plus b. Conjugates. What do you mean by conjugate of this? See, I will explain you while doing problems why you multiply the denominator with its conjugates. Okay, so if you multiply the denominator with its conjugates, so whatever may be the root, that root will be C, a plus root b. So its conjugate is a minus root b. So when you multiply these two, so you will get a square minus root b square. So this root will get cancelled. So now there is no root. So in order to eradicate the root of any expression, you have to multiply it with its conjugate. Now the conjugate of root a plus b is root a minus b. So what is conjugate that we are learning? So conjugate of root a plus b is root a. First term will be same and change the sign of second term. Second term is plus b, so you will write minus b. So this is called conjugate of this term. Clear? Now a minus root b. a minus root b. So you want to write conjugate of this a minus root b. So first term as it is, that is a, and second is minus root b, so you will write plus root b. Clear? This is called conjugate. Have you got it? So conjugate of a minus root b is a plus root b. Nothing you have to do. First term you will write as it is and you will change the sign of second term. Clear? That is called conjugate. Now we will learn few problems here, rationalizing the denominator. So first we will do your textbook, then we will do few extra problems. Okay. See, rationalize the denominator. Exercise 1.5, textbook, question number 5. First one. 1 upon root 7. You have to rationalize this. 1 upon root 7. Denominator. So here it is root 7. So 1 upon root 7. So you will multiply by root 7 and you will divide by root 7. So answer will be 1 into root 7 is root 7 upon root 7 into root 7. Root 7 the whole square. So the square and root will get cancelled. So root 7 upon 7. So here now there is no. See, here root was irrational number, you have converted into rational number, so it is called rationalizing the denominator. Clear? So first one. Now second, 1 upon root 7 minus root 6. The value should not change and there should not be any, what we can say, irrational number in denominator. Now you will see the conjugate. You will rationalize with its conjugate. So conjugate of root 7 minus root 6. The conjugate of root 7 minus root 6 is root 7 plus root 6. So you will multiply this. See, 1 upon root 7 minus root 6. You will multiply its denominator with its conjugate. So root 7 plus root 6 and here also root 7 plus root 6. So both of these will get cancelled. So now both will remain same. So value of this expression and this expression is same. What you have done? You have multiplied numerator and denominator by the conjugate of denominator. So conjugate of root 7 minus root 6 is root 7 plus root 6. So now what you will get? 1 into root 7 plus root 6. So root 7 plus root 6 upon. Now see a minus b and a plus b. So no need of writing this step. You can write directly also. So a minus b, a plus b. So a square minus b square. See, if you don't want to write this step, don't write. Directly you can write root 7 plus root 6 upon roots a minus b, a plus b. So a square, root 7 square. Root 7 square is 7. Root 6 square. Root 6 square is 6. See, root 6 square is 6. Sign minus. 7 minus 6. So that you will get root 7 plus root 6 upon 1. Upon 1. No need of writing. So we can say rationalize, both these values are same, equal to, they are same, but now see in denominator there is a rational number 1. So you have rationalized the denominator. Have you got it now? What do you mean by rationalizing the denominator? Clear? So now this second. Now we have third. 1 upon root 5 plus root 2. So what you will do here? You will multiply 1 upon root 5 plus root 2. So you will multiply and numerator and denominator by the conjugate. So conjugate of root 5 plus root 2 is root 5 minus root 2. Here also root 5 minus root 2. So now 1 into this. So you will get root 5 minus root 2 upon a plus b, a minus b. Like this way. A minus b, a plus b. So root 7 square. Root 7 square is 7. Root 6 square. Root 6 square is 6. Clear? So now root 5 the whole square, so that is 5. And root 2 the whole square, that is 2. Here minus. So what answer you will get? Root 5 minus root 2 upon 5 minus 2, 3. So now there is a rational number in the denominator. Have you got it? This is called rationalizing the denominator. Now fourth one. 1 upon root 7 minus 2. So here what you will do? 1 upon root 7 minus 2, you will rationalize the denominator, means you will multiply numerator and denominator by the conjugate of denominator. So its conjugate is root 7 plus 2. Here also root 7 plus 2. So 1 into root 7 plus 2. So that is root 7 plus 2 upon a minus b, a plus b. So a square, that is root 7 square. If you want to write this step, right, otherwise no need. Minus b square, b is 2 square. So what you will get? Root 7 plus 2 upon root 7 square is 7 minus root 2 square is 4. So answer will be root 7 plus 2 upon 7 minus 4. 7 minus 4 is 3. So this is called rationalizing the denominator. So now we'll do few extra problems. We'll do. Extra problems. Okay. See now. Rationalize the denominator. Just a minute. See, I am doing now. If root 2 is equals to 1.4142, find value of, you have to find the value of root 2 minus 1 upon root 2 plus 1. This value you have to find. So one way of finding the value is you will put the value of root 2, 1.4142 minus 1, 1.412 plus 1. So you will get a rational number, then you have to find the square. So it will be very tedious and time consuming. So what you will do here? So now here, see, I will solve this first. Root 2 minus 1 upon root 2 plus 1. So now what I will do, friends? I will rationalize the denominator. See, root 2 minus 1 upon root 2 plus 1. Now conjugate. Conjugate of root 2 plus 1 is root 2 minus 1. And here also root 2 minus 1. I have got it, friends. Nothing I have done. Problem as it is. Root as it is. Just I have rationalized the denominator. See. So what you will get here? So that is equals to, see, root 2 minus 1 into root 2 minus 1. So you will get root 2 minus 1 the whole square. Clear? Upon a plus b, a minus b. Have you seen? A plus b, a minus b. So you will write root 2 the whole square minus excuse me, 1 the whole square. Clear? So now what you will get here, see, that is equals to root 2 minus 1 the whole square. I am not expanding this c. Why? I will explain you. Why we are not expanding, sir, a minus b the whole square? That is reason, see, I will explain. Root 2 the whole square is 2 minus 1, 1 square. So 2 minus 1 is 1. So what you will get here? You will get this way. Root 2 minus 1 the whole square upon 1, no need of writing. 2 minus 1 is 1. So now this square and this root will get cancelled. It is a whole square, that's why. Okay. If it is whole square, then only it will get cancelled. So this root and this will get cancelled. So what you will get? Root 2 minus 1. So now root 2 minus 1. So root 2 is 1.4142 minus 1. So answer will be 0.4142. This is our answer. Have you got it, friends? See, here one thing you have to remember. I am writing a note. This is note. See, root a minus b the whole square. So this is here, there is a whole square. So this root, this square and this root will get cancelled. Answer will be a minus b. But if this is the case, a square minus b square, then you cannot cancel this square and this root, this square and this root. That you cannot cancel. So this is not equal to a minus b. Here there are two squares. There should be only one whole square should be there. Then only this square and this root will get cancelled. If there are two different squares, then you cannot cancel this. Have you got it out? So this is not equal to a minus b. Clear? So remember this. Very important note. This note you have to remember. Clear? This you have to remember now. Okay. Now we'll do one more problem. See. Extra problem 1. Now extra problem 2. Simplify. Simplify root 3 minus root 5. Root 5 plus root 3 upon 7 minus 2 root 5. So how I will write this? See, this is our question. So what I will write here? Root 3 minus root 5 into, this is root 5 plus root 3. So commutative property a plus b is equals to b plus a. I can write here, see, a plus b is equals to b plus a. So here root 5 plus root 3 is equals to root 3 plus root 5 upon this as it is 7 minus 2 root 5. Now a minus b, a plus b. Here identity a minus b, a plus b is equals to a square minus b square. So root 3 the whole square. So root 3 the whole square is 3 minus root 5 the whole square. Root 5 the whole square is 5 upon 7 minus 2 root 5. Have you got it? This is the case. A minus b, a plus b, so a square, that is root 3 square. Root 3 square is 3, b square. Root 5 square is 5, 3 minus 5 this. Now you will rationalize the denominator. You should know that there should not be any irrational number here. So you will rationalize this. So what you will get here? 3 minus 5 minus 2 upon 7 minus 2 root 5 into conjugate. Conjugate of 7 minus 2 root 5 is 7 plus 2 root 5. Here 7 plus 2 root 5. Have you got it, friends? Nothing, just rationalizing the denominator. So you have to multiply this denominator with its conjugate. So now what you will get? See, minus 2 into 7 plus 2 root 5. 7 plus 2 root 5. I am not multiplying this. See, keep as is. Upon a minus b, a plus b. So a square, you know, a square, 7 square minus 2 root 5 the whole square. So answer will be here minus 2. Again I am not multiplying this. See, not necessary. Why? Because some value you will get here in denominator that might get cancelled with 2. Okay, so till when denominator is not clear, don't do any change in numerator. Upon 7 square 49 minus 2 root 5 square. See, 2 root 5 the whole square. So what do you mean with this 2 root 5 the whole square? 2 square 4. Root 5 square 5. 4 into 5. So that is equals to 20. So this is 20. So now that will be equal to 49 minus 20, 29. So minus 2 into 7 plus 2 root 5 upon 49 minus 20 is 29. So now you are not able to get cancelled. So this is your final answer. Clear? And if you want to multiply, you can multiply. Minus 2 into 7, minus 14. Minus into plus, minus 2 into 2, 4 root 5 upon 29. This is our answer. Have you got it? This is our answer. Again, we'll do a few problems, extra problems. See, question number 3. If x is equals to 1 plus root 2, find value of x minus 1 upon x the whole cube. This value you have to find. So what you will do, you will put here x, 1 upon x, then you will write cube, whole cube. See, this is whole cube. So it is very difficult. So how to solve this problem? We have x, we don't have 1 upon x. Clear? We don't have 1 upon x. See now solution, x is equals to 1 plus root 2. So we got x this. Now we want 1 upon x. So now 1 upon x means 1 upon 1 plus root 2. 1 upon x. So 1 upon x. X is equals to 1 plus root 2. Now we'll solve this. So you'll multiply with its conjugate. See, 1 plus root 2 into conjugate of 1 plus root 2 is 1 minus root 2. Here also 1 minus root 2. Multiply numerator and denominator by the same number, the value will not change. So that will be 1 minus root 2 upon a plus b, a minus b. So a square, 1 square is 1 minus root 2 square is 2, 1 minus 2. Clear? So what you will get here? So you will get that is equals to 1 minus root 2 upon minus 1. So that will be equal to what? Minus 1. See, 5 upon minus 1 is equals to what? Minus 5. So this equals to what you will get? So that is equals to minus 1 minus root 2. If minus is in denominator or numerator, wherever it will be, it is considered as the whole fraction. Clear or not? So that is equals to minus 1 into 1, 1. Minus into minus plus. So I can write here root 2 minus 1. See, multiply. Minus 1 into 1, minus 1. Minus into minus plus root 2. So root 2 minus 1. So 1 upon x is equals to root 2 minus 1. Have you got it? Now you have to find x minus 1 upon x. So now x minus 1 upon x is equals to, what is x? X is 1 plus root 2. Minus is for whole 1 upon x here. This minus sign is for whole 1 upon x. So whole 1 upon x is root 2 minus 1. So we'll solve this. 1 plus root 2 minus root 2 minus into minus plus 1. So this will get cancelled. So 1 plus 1 is equals to 2. So x minus 1 upon x equal to 2. So therefore x minus 1 upon x is equals to 2. Now you want x minus 1 upon x the whole cube. So that is equals to 2 the whole cube. That is equals to 8. Have you got it, friends? So this type of problems are there. Clear? So this is question number 3. Now question number 4. If 3 plus root 7 upon 3 minus root 7 is equals to a plus b root 7, find a and b. Important problem. This type of problem will be asked. Have you got it? So now, what is given? Here a plus b root 7 is equals to this. Clear? So now you know we'll solve this. Or you can say now, see, a plus b root 7 is equals to 3 plus root 7 upon 3 minus root 7. So that is equals to, I will solve this. You know, rationalizing the denominator. Clear? So 3 plus root 7 upon 3 minus root 7, I will solve this. So I have to multiply with its conjugate. So conjugate is 3 plus root 7. Here also 3 plus root 7. So we are multiplying numerator and denominator by the same number. So that will get cancelled. Value will not change. Both are equal. Have you got it? Now, 3 plus root 7 into 3 plus root 7. So 3 plus root 7 the whole square upon a minus b, a plus b. So a minus b, a plus b. So a square minus b square. So a square minus b square. So 3 square minus root 7 the whole square. Okay, now you will multiply this. 3 plus root 7 the whole square. A plus b the whole square. So a square, 3 square. 3 square is 9 plus 2ab. So 2 into 3 into root 7. You know 2ab. A plus b the whole square. So first a square. 3 square is 9. Now 2 into first term into second term. So 2 into 3, 6. 6 into root 7. So 6 root 7 plus b square. So root 7 square is 7 upon 3 square is 9 minus root 7 square is 7. 9 plus 7, 9 plus 7, 16 plus 6 root 7 upon 9 minus 7, 9 minus 7, 2. Have you got it? So 16 plus 6 root 7 upon 2. So you can multiply this 2, divide 2 by both the number, or you can take 2 common. So 16 by 2, 16 by 2, this 2 divide both the numbers. So 16 by 2, 8 plus 6 root 7 by 2, so 3 root 7. So therefore you got that Therefore, here it is a plus b root 7. So, a plus b root 7 is equals to 8 plus 3 root 7. So, you compare this. So, in place of a we have 8. In place of root 7. Here b is the coefficient of root 7. So, here coefficient of root 7 is 3. So, if you compare both this, so you will get therefore a is equals to 8. So, therefore, a is equals to 8. And b root 7, here 3 root 7. Root 7. Coefficient of root 7, 3. Coefficient of root 7 is b. And b is equals to 3. So, a is equals to 8 and b is equals to 3. So, I hope you understood this type of problem. Nothing you have to do, just you have to rationalize this. You keep on solving. Then you compare with this a plus b root 7. You will get the answer. Clear? So, this is the case. Now, see. Now, we will do one more problem. Question number 5. See, x is equals to root 3 plus root 2. Here, root 3 minus root 2. And y is equals to root 3 minus root 2 upon root 3 plus root 2. See, reciprocal of this is y. Then find value of x plus y the whole square. So, you want to find the value of x plus y the whole square. So, x is given here. Now, see, x is equals to root 3 plus root 2 upon root 3 minus root 2. So, you will solve this. So, you know how to solve. Rationalize the denominator. So, root 3 plus root 2, 3 minus root 2, root 3 minus root 2. Multiply, conjugate of denominator, root 3 plus root 2, here also root 3 plus root 2. So, both are same, you multiplying. So, root 3 plus root 2 the whole square upon a minus b, a plus b. Clear? So, what you will write? Root 3 the whole square minus root 2 the whole square. A minus b, a plus b, a square minus b square. Clear? So, now this. Okay, I will write here. See, come on. Now, root 3 the whole square is 3 plus 2 into root 3 into root 2. 2 root 6 plus root 2 the whole square, b square, that is 2 upon root 3 square is 3 minus root 2 square is 2. So, 3 plus 2, 5 plus 2 root 6 upon 3 minus 2, 1. Clear? So, that is equals to how much? 5 plus 2 root 6. 5 plus 2 root 6. Therefore, x. So, you got the value of x. Similarly, now you will find the value of y. Okay. So, what is y here? See, we have y is equals to root 3 minus root 2 upon root 3 plus root 2. This is y. So, now we will solve this y. So, you know what you will do here? Root 3 minus root 2 upon root 3 plus root 2. So, you will rationalize the denominator by the conjugate of denominator. So, conjugate of denominator is root 3 minus root 2. Here also root 3 minus root 2. Got it? Then root 3 minus root 2, root 3 minus root 2. So, root 3 minus root 2 the whole square upon root 3 minus root 2, root 3 minus root 2. Both are same. So, whole square. Now, a plus b, a minus b. So, a square minus b square. Now, a minus b the whole square. So, a square, root 3 square is 3 minus 2ab, 2 into root 3 into root 2. So, 2 root 6 plus b square, root 2 square is 2 upon root 3 square 3 minus root 2 square 2. So, that is equals to 3 plus 2, 5 minus 2 root 6 upon 3 minus 2, 1. So, that is equals to 5 minus 2 root 6. Therefore, y. So, you got the value of y. X and y. Now, you have to find, what you have to find out? See, you have to find out the value of x plus y the whole square. So, first I will find here x plus y. So, now x plus y. So, how much x is? We have find out here. X is equals to 5 plus 2 root 6. So x is equals to 5 plus 2 root 6, 5 plus 2 root 6 plus y. Y is 5 minus 2 root 6. So 5 minus 2 root 6. So that is equals to this cancel. So 5 plus 5, 10. So therefore x plus y is equals to 10. Now you have to find x plus y the whole square. So that is equals to 10 the whole square. That is equals to 100. So x plus y the whole square equal to 100. Clear, friends? So with this I am going to complete. There are many such problems. I will give the assignment. Keep on practicing. If you have any doubts, please feel free to ask me. So thank you very much.